Hello, dearies. Welcome to Undersampled Radio, episode 53. We have probably an interesting situation going on today because I'm starting off in the reverse format of my usual broadcast situation, which is I have my Linux box over there hosting the Undersampled account, and I'm on Windows. So expect me to crash into oblivion at some point, as per usual. Hi, Matt.
Hi, how's it going? I'm on a phone today,
We're
Android,
professionals.
on a Nexus 5X.
Yeah.
So I really liked the Nexus 4, and I said to myself, I'm just going to buy 5 of these and use these forever. But I really like the 5X now more than I did the 4 even. But I've got the reason I'm down there twice today
On the bottom of the screen.
at the bottom of the screen, in case you're watching, is I've got my laptop on the Ethernet as backup, just in case something horrible happens to my Wi-Fi.
Yes, indeed.
But I'd quite like to hear. So, just briefly, Graham, what is your Linux machine? This is something you built yourself, I assume.
Oh, yeah, the hardware. Yeah, it's just a workstation motherboard with some wood. It's got a decent graphics card. I built this particular box many years ago, so it's antiquated now, but
It's a workhorse.
it does the job for undersampled radio.
Your vision is crystal clear. I can see.
Thank you.
Matt's camera is obviously, very very pixely.
Yeah.
Can I call it? Yeah. And yours is like.
I think that's a function of internet speed.
May also be that you're the only one that actually shaved today.
That's right.
I'm just that's full resolution. I'm just naturally fuzzy. Bert, I wouldn't mind hearing what sort of computer you're on, because you already mentioned to us before we started that you're on a Linux machine, but I assume you built it yourself.
No, you can assume that, but I'm not into that kind of thing.
Okay.
I have a 8-core thing from 2011, but it's still reasonably okay. But I bought it to be reasonably okay for at least 8 years. So
Perfect.
Okay.
That worked. Yeah.
Yeah.
It's a good machine. Yeah.
Got 2 more years to go on it.
Yeah, exactly. And especially because the screen kept growing. So now I have this 4K, 2K monitor, and that means that I don't like working at laptops anymore. It's
Yeah, right.
Also the keys, I don't like it at all.
Not enough keys. What is the 4K screen? Is that worth the upgrade?
Absolutely. There's no doubt about it.
Oh, yeah.
and it's less than it used to be. I think it's still like, it depends on your currency, but I think it's still like 600-700 euros. But you get,
that's not bad.
You get it. It's unbelievably nice.
It's nice because
under 20,000 Canadian.
Instead of having 2 monitors, you can have 1 monitor and fit the same amount of junk on one screen. It's really nice.
All your junk in one place.
Hey, can you tell? Did you see? Hold on. Did you guys see James Mickens' speech about how I became a developer? He talks about optimal window placement. It's hysterical. You can, I don't know, just look it up on YouTube. James Mickens, I think it's called How I Became a Developer. It's so funny. Matt, did we have a contest last week or something?
Yeah, we did, didn't we?
Uh-huh.
Oh my goodness. And you're going to ask me?
No. I thought you were prepped. I'll do it if you okay, so
I can remember the question.
Okay,
which was a question that actually where did I see it? Oh, I bought this little book when I was in Cambridge, as I already mentioned last week. I bought a little book of puzzles, and it's a book of puzzles by a math professor, and he gives these puzzles to his undergrads. And I thought, oh, that sounds cool. And one of the puzzles in there was this coin puzzle, and the challenge was to make $1 out of the standard US or Canadian coins, so 1 cent, 5 cent, 10 cent, 25 cents. And I couldn't believe I'd never heard this puzzle before, because it seems so sort of elementary and it's so elegant. And so the puzzle is to make $1 out of 50 coins exactly. And since we were trying to give away one or more copies of 52 things, we had a follow-up puzzle, which was to make $1 out of exactly 52 coins. And the follow-up puzzle to both of those is, which I think we didn't ask people for, because we just asked people for one solution. But the follow-up question, I guess, is how many ways are there to meet both of those requirements?
True,
and what happened,
we should have asked that. And so we received many correct answers. And so as promised, we drew the winner randomly out of a hat. The hat in this case being a one-line Julia script written to announce a random integer. So the winner this week is Jorge Fernandez.
Nice.
On Swamp. So we'll be sending Mr. Fernandez.
I'll send Mr. Fernandez a couple of 52 Things books. The one that just came out, 52 More Things You Should Know About Paleontology. And maybe I'll just ask him which other one he'd like. Yay.
Congratulations. Cool. No, that was fun. It turns out that there are, how many ways, Matt, did we
well, I remember that there are only 2 ways of doing it for 50 coins.
Right. Okay. 1, 2. And there's 4 ways to do it with 52 coins.
Right.
I'm not
including quite an elementary way, or at least one that it seemed obvious enough to me that I couldn't quite believe I hadn't thought of it while we were on air last time.
50 pennies and 2 quarters.
There you go.
Why don't you introduce our guest, Matt?
Okay. Yeah, I'd love to. This week we're welcoming Bert Bril. Bert is one of the co-founders of DGB Earth Sciences in Enschede in the Netherlands. They're an awesome software and consulting company. I'll let Bert tell the story of the founding, because actually I don't know that I've heard that story, but I'm quite interested in it. So along with Paul de Groot, because I believe the company was called De Groot Bril. That's how I kind of came across it when I started my career way back in the late 90s, probably. And then it changed to DGB at some point. So welcome, Bert.
You modernize, right? You start with the full-length thing, and then you say, well, okay, let's make the abbreviation, because that's how it works. Fast days.
Yeah, exactly. Everyone abbreviates it anyway. So where are you in Enschede right now?
No, I'm in Utrecht at the moment, and Enschede is actually pronounced Enschede, but that's obvious. If you can speak Spanish, you can also say Enschede.
Enschede. Okay.
So I would say Graham should be able to pronounce it, because he's near.
Because I'm near what, Mexico?
Yeah, you should be speaking Spanish, right?
Yes, I wish.
Enschede and Paul de Groot, then he's also his. Yeah. So what do you want? You want to know the story of the foundation of the de Groot Bril Earth Sciences? I can do that on many levels. So I can say something dance. Sorry, first one.
Please perform it as a piece of dance composition.
Okay, well, it's going like that. Dance isn't really a level.
No.
Sorry, I have to say
it's
that.
More of a medium.
No, but let's just say that in 1992, Paul, from 1990 to 1992, Paul was doing all kinds of stuff within Shell, where he worked there, with neural networks to predict all kinds of, what we would call now lithology, fluid prediction stuff on seismic data. So directly with neural networks, which was then, at that point in time, revolutionary, and nobody really did it. At a certain point, he discovered all kinds of fun things, and he wanted to start for himself. So he more or less started for himself, and then he came into contact with TNO, which is let's say, almost like a Dutch national research organization. Nowadays, there's still TNO is still in Utrecht, also in this town, with the Dutch. It's the National Dutch Geological Survey, combined with TNO itself. So it's quite a big, for our standards, research organization. At least it's a national thing. He came into contact with these guys and they said, well, if you come to us, you can basically put in your stuff. Let's develop it here because we know how to do that in 3 years. And then afterwards you can take your stuff and leave. And we give you like 200K now and you can get it back when you go away. Or no, it's the other way around. He got 200K and he had to pay it when he went away. So in those 3 years, he first had 2 years of development and he thought he had a big thing there. And then we get to another level, basically, is that we also we played football, soccer. We do call it soccer. We call it football. And it's just, we did that against the guys of artificial materials and rubber. So that was every week on Thursday. And at that point in time, we were always winning. So it was always a good thing. But at the end, Paul came to me and he said, when we were just in the lockers, as you call it, he said, well, I've been talking to your direct manager and I can get you. What I've seen is that we have a problem. We have 95% of the software is made. And for some reason, we can't get the last 5% done. So I said, well, I heard that before. He said, I've seen that you can actually do that. I said, well, it's too much honor and everything. And he said, but explicitly, you have the tendency to rebuild everything, and you can't do that here. It has to be just finished. I said, well, I'll see what I can do. I'll first make an inventorization of what we have, and then from there we can go. So I did like 2 weeks of actually 1 week. But after 2 weeks, I came to him with 2 A4s of paper, so two overviews. There were 2 diagrams on, exactly the same diagram. The first one I gave him, I said, I think this is what you want. So I did a lot of talking, and there were like 12 functions on it. Like you want to read all the data, then you want to extract all kinds of stuff from that, and etc. At the end, there was like, and here you apply it and you get results. And we discussed it. He said, yeah, that's exactly what I want. I said, okay, and then the next one is what you have now. And basically one of the things was colored in half, and the other one, there was one other one which had like 10%. And I said, the rest you don't have. It's not there. Everybody's just giving you thick reports that we're printing out, and they had stuff on the screen directly from some kind of, it wasn't there. It's simply not there. Sorry, but that's what software houses do. They basically print out thick reports, and that's what you have. They make all kinds of stuff that you never need, but it's good for their CVs. It's good for the resume.
The requirements have been met or whatever.
No, they don't.
But the actual goal was never reached.
No, it's not even that. There wasn't even a requirements document. There was nothing. There were only documents of interfaces that were printed out. But I can go on and on. But it's really like they had chosen libraries to work with. They had all kinds of functions that would be needed in the future, etc. And if you look up the history of OpenSpirit, you can recognize exactly the same thing. It's exactly the same thing. There was this company, and they made all kinds of stuff first that didn't have anything to do with the actual thing that needed to be made. But that was the idea of the day. I mean, that's waterfall model. You just start with all kinds of stuff on this extremely high level, and then you just generate all kinds of reports, and basically I just cut right through everything and said, we have to rebuild it. There's no way I'm going to work with this kind of shit. Is this beeped? I mean,
Carry on.
I'm not used to.
No, but so were you? Were you at TNO as well, or were you an external guy at this point?
So I had already worked there for like 2 years.
Okay.
And that's what Paul saw, what I did. What I did was basically I went on this project and I made sure there were actual things there. Which was
until that locker room conversation, you've been working on other stuff.
Yeah, absolutely. And that's why he knew he wanted me.
Yeah. So
from then, he got me, and I basically rebuilt the thing in less than a year, and then there was a big fight because TNO wanted to keep it because it was so successful. It really worked, and
This
everything.
is way better than we thought it was going to be.
Yeah. Well, this is actually so. At a certain point, we got investment from the same company, from TNO. It's not really a company, but they also have an investment branch, which is basically meant for this kind of stuff. They put money into these spin-offs.
Right.
It was already in 1995. So, and we talked to this guy, and this guy, he said, and they said, we told him like, okay, there's big problems, they're threatening all kinds of stuff. He said, this is exactly why I want to put money in you guys. When it's good, it always happens. This is the thing that happens.
Yeah, right.
Because the people that have first neglected you and say, oh, it's good, they suddenly realize there's something real there, and they get angry. So they want to keep you. And of course, we went out and so I had to rebuild everything again because there's the difference between. But so the first 2-3 years I worked like 90 hours a week, really. So that's not an exaggeration, because it's really hard to work 90 hours a week, but I really did it. But then at a certain point, we had a project called GeoPro, and we did a lot of stuff with it. And then came in that we could actually, so the next part is really Statoil related. So at a certain point, Statoil came to us and said, well, we have this thing here. We know how to do it, but we can't get it done in any software. So what the problem was that they wanted to find chimneys, these things in seismic data where you can see where the hydrocarbons went, and that's because it's a little bit chaotic, it's always vertical. And they said, well, we have this idea of, just cross-correlating some traces and then do some stuff. And
so this was Roar Hegland.
Exactly, Roar Hegland, the famous one, who's still, but it's also Paul Meldal. Don't forget, Paul Meldal is really like the artist, and Roar Hegland is really the guy who wanted this kind of stuff, and then they were friends, so I gather. But anyway, so they went together to us. They came to us, and because we already did some work for them. And then I started to think about what could really bring out these things. So we devised neural networks that were basically working on multiple levels of the data, and then do all kinds of attributes. So we had to have an attribute engine. For that, we took in Chris Tingdahl, which is also like history, because you might have known him. Chris is now actually no longer in the oil industry, which is a big bleed off, because he's really, really good.
Yeah,
it's actually the best designer I've ever met. Wow. And that probably includes me. no, really. I mean, he's really good. But he's now working for a software security company.
Right. Well,
so
it's too bad.
Anyway, so he made an attribute engine, and we started working with it, and we made, we could really get out these chimneys that they wanted, and on the maps you could even do lots more with it. They showed all kinds of features about sealing capacities and hydrocarbon migration paths and those kind of things. So that was a real success. And then at a certain point, they said, why we have to go further. We have to basically make software for everybody. So we first started with Detect in cooperation with a company from Norway that I won't mention here. And that company there were really talented people there. The only problem was that they were the 95% people again. So no, that's not really true. They could actually make something. The problem is they always said, we are flexible, we can do anything. And then we said, well, if you can do anything, please do this, because that's what we now need. And then they didn't do it because they were doing other things. Right. And that was like, and the last bit, well, the real problem that we had at a certain point, that Paul was at a conference, I think it was EAG conference, and we were next to the guys from Petrel. And these guys from Petrel, they had this nice spinning demos in 3D and everything. And we had this thing that went like, like 0.5 frames per second. And it was like, what the hell? What is going on? You can do that on a laptop, and we have this big machine here. And then the guy said, yeah, I should have put it in texture. Yeah, it's like, yeah, I could have done that, but I put it on a horizon with triangles, etc. And it wasn't. And then 2 weeks later, he had it, and we were just like, unbelievable. Like, how can you do this? How can you? Because they were simply not interested in what we did. So at a certain point, we cut that off and started all agreed that it wasn't, because it was a Norwegian company and they had brought us in contact with them. They were actually, they would have been a good match, but we couldn't just get on the level of actually making it work. This is actually one of the common things I'm always in. I always have this problem with people thinking on all kinds of technical levels and details. But it's important to get something really there that's really working. That's not just vaporware. Sure. But anyway, so we had to then go on with Detect ourselves, and then we got this idea. I think Paul was the first one to. Well, we had always been playing with it, but Paul at a certain point said, "Well, we can just do it now. I think we should just go open source." So we're talking about 2002, maybe. That was unthinkable for most in the oil industry. Yeah. Open source. I mean, it's still like if you have something from academics, they just throw it over a wall and then it's open source. But we really started to figure out how to do this thing, how to make it actually work, what kind of stuff you have to do, how to open up the interfaces so other people can basically also program against it, etc. And, by 2017, we're probably not the most open software that's around there. Although, if you look at advertisements of, let's say, for example, Ocean from Bert Bril, they call themselves open.
Sure.
Well, they're open if you start paying them $30K in American dollars, not Canadian dollars.
So how long was it between the time that you guys spun off on your own and released all that open code?
That is like 8 or 9 years. 8 or 9 years. And in the meantime, I had like 2 open heart surgeries. So you can see there's lots of things going on there.
Wow. So what's going on now? Is it still active? Is OpendTect still actively being developed?
Yes, that's what I'm doing all day, basically. Yeah. My job is to, I basically do a lot of work with the people in India. But my goal is, what I'm doing now is make sure that we can get to next releases, etc. So we work, our users do a lot of pushing in terms of what they really need. And I do pushing on the level of that we really become like cloud ready and those kind of things. So I really make sure that the next release will actually have something that's not outdated. And that's, if you look at how old this is, it's like 15 years old. Mm-hmm. And I think it's still alive. It's still being used.
Yeah,
people are still enthusiastic. And, although I think you could make stuff nowadays quicker with Python, etc., I still think it's good value. So we're still in for like quite some years that we can do stuff, especially as we have some nice products and nice things that are quite unique.
How, for the audience who doesn't know much about OpendTect, how does one contribute to the project in terms of donating code or whatever?
Well, I'm actually not the best person to say, but you should talk to Wayne Mogg or somebody like that. But you just download everything, you build it. It's now dependent on only 2 real things, Qt and OSG, which are both open, so no problem. And then there's like this tool that you can make your own development environment, which I never use because I do a little bit different. But then you can start building the plugins. So a plugin is basically you don't have a main, but some functions are called from OpendTect, and then you can use the entire interface of OpendTect. From early on we have chosen not to make special APIs. Mm-hmm. So, which is the trend, is like you basically have like a body of software and you make a shell of APIs around it, but we basically just deliver all the objects as they are. So there is no special API at all. Everything is just as we also program. So there's no, you just have the same situation as we people at DGB have. The only thing is that at DGB we have a couple of libraries that we use internally, like neural network stuff, dip steering, all kinds of fault tools to detect faults and those kind of things. But that's basically it. Oh, and of course Horizon Cube technology, which is like comparable to well, what we basically think is that if you make horizons, if you pick them, then in between the seismics contains the information for all these micro horizons. That's basically what we call Horizon Cube. And once you have these things, you can basically do many things that you couldn't do before, because instead of always having to do horizontal comparisons, you can now follow the dip, because you know that this dip is actually, in many cases, a real timeline, a real stratigraphically important thing.
Yeah, right.
So it opens up all kinds of possibilities that's just go way beyond flattening things. Yeah,
How does it?
Yeah,
does
you can
it
really see
pick
how.
surfaces in between the horizons?
Yes, in a way it does that, but it uses more hardcore geophysics to.
Is it using plane wave destruction to figure out where the surfaces lie, what the geometry?
No, it's not really the surface. The only thing you really need is what is the local dip.
Yeah.
In your seismic data. That's really what you need. And then of course there is always the problem of, if you go in 3D, if you go from here to there and you come back, you never make the loop completely right. So that's the kind of struggles that we still have, and everybody has them, because it's really not. But once you have this in place, you can do much better, like coherency or a similarity, we call it. You can do all kinds of continuity stuff much better, but you can also do attributes along these micro horizons at any point. And that means you can make new cubes that are not made by making attributes in a horizontal way, but following the real stratigraphy that is in the seismics.
Very cool.
Yeah, well, that's what I thought. It's actually not something I've done a lot about. It's something that the rest of the team have done. I've been one of the things that I've done all the times, for example, is SegWi handling. Basically because I just couldn't give it to anybody else. Not because I like it, but because it's too shitty. It's really such horrible stuff. I've wasted. Well, I put that, I think, in one on Slack lately. I put like a year of my life into this dung heap that they call SegWi. It's really awful. And then we got SegWi revision 1, and that was really good. The only problem is there's so many non-SegWi, so that actually gave me more work. But in the end, once you have people in SegWi, and we could actually be making SegWi revision 1, then everybody at least knows where the inlines and crosslines are. You know, where are the coordinates? Yes, we know now where they are. Thank God. And then, of course, we've had this discussion, but SegWi revision 2, I think, is a step back, because we can't do all these things, and it just requires us to make software that is countering all the problems that you can get.
Right.
I don't have the problem of my seismic data isn't variable length, doesn't have all kinds of different sample rates. It needs stuff.
Is that the problem, that the format is basically trying to be all things to all users? Like it's just so flexible that it's not a format anymore.
I could look it up, but I probably typed like stop trying to make a complete database out of this SegWi file. It's not what we want. What we need is to have something that's even interoperable between domains. That simply gives me a couple of samples that I know where the bleeding samples are. Sorry, I have to be careful. I'm Dutch, we can say anything, but you guys can't probably. So I have to be, but that's all you need to know. Where are these samples? Where are they located?
Yeah.
That means, of course.
I mean, basically it needs more rules and fewer sort of allowances and ways of coping with. Yeah, I agree. Like, well, I don't know. I mean, I'm not a seismic researcher, but
document for BG at a certain point. So British Gas, well, I made it for British Gas, but they didn't really ask for it. But I was really like, what if we would want to make this format? What would we need to do? And there's all kinds of things like we would have to have, on every platform, all languages and everybody. But one of the things is what you need is for this metadata, you need an independent group of people who make decisions about it.
Yeah.
And they have to make decisions, but there's now all kinds of tools that you can make these decisions, not hurt anybody.
Right.
One thing I'm thinking of is an intelligent search tool. So, okay, you have to think about, because if you're programming, that means if you get programming examples, very often they say you can get, let's say, the short point number by doing this and that and that. The problem is I have to be able to get it reliably. And if they say, well, if it's not there, it may be there, or it may be in that, it's already no longer an issue, because then I need human intervention, or I need big time artificial intelligence. So what do I think of? I think of a system in which you can simply say, I need something that is described like this. If it isn't there, then I would like to have that. And if that isn't there, I would like to have that. And how can I do that? Because I can read the menu. I can read what the standards committee has said. The standards committee has said, if you're going to add a short point number, then it has to be in this way. And you can get this sub-label on it if it is a short point number that is from the field. And you can get that sub-label on it. So basically, you're just describing, not like this is like a dictator, but you're just saying, if you do it, try to do it like this, because that guarantees maximum interoperability. And that's what you want. Because when you make software, you want to be able to read as much data, as many types of these files as possible. Even from the earthquake guys. I have nothing against the earthquake guys. It's just that I feel that their problems are a bit different from mine.
Yeah.
But if at least I know how to find the stuff that I need, I can either get it or I can throw the towel. But that's it. So that would, for me, would be the top priority. It's nothing to do with super fast access and parallel execution. It has something to do with real simple project management and simple procedures around it. And I'm always saying we need somebody like Matt to lay out. It has to be, there have to be people that you cannot dispute. They have the heart at the right place, which already rules out maybe even me, but especially the guys from the big companies.
Yep.
Because they're always in political. They're always doing this. They can never speak freely.
No.
And we don't need it, because we have enough people, retired people. We have people like Matt who are simply above all suspicion. Right? And it's not like, so we should just grant them some of the SEG money that I pay every year. And that's it. So that for me is the important part. The important bit is, how are we going to manage this whole thing? How are we going to make sure that we have something that is an attractive proposition even for the oil companies?
Yeah. I know, I almost feel like...
And my guess,
Well, just like, I wish we had sort of rapid data access problems and like arbitrary file access problems. Like, I wish those were the problems we got to think about, but actually we just get to think about, where on earth are these traces? How are they organized? Exactly. Like, those are the problems we have.
And that's why you say Revision 1 was it was almost a revolution. Revision 1 told me exactly where to find what I need.
Right.
What do I need more? So currently, I think let's just stick with SegWi files, but like make a standard access layer on top of it, because that's what I need. I need to know where to find my stuff, and how it gets to me. I don't care one bit. But I want to be able to
make interoperability much more functional. I mean, you're talking about all these companies now who are, as you say, putting their software in the cloud, having algorithms work in distributed systems, and being able to incorporate open data from disparate sources in an automated way is only possible if you can, do that in a sort of pervasive, in a reconcilable manner.
one guy that I work a lot with is Charles Jones. He's now started his own company too. He worked for British Gas until I think the 1st of January, but maybe a little bit early. And he's now has his own company called Also Key, and they're basically doing this with artificial intelligence. So just before he went, because they were taken over by Shell, as you may know, British Gas, Shell. I think it was, well, maybe I'm a factor wrong, but it's like 1 million SegWi files, and they all figured out where the inlines and crosslines and those things were with, well, let's say high-level artificial intelligence. So and I can see how to do it, but it's just that I don't have the time.
It is kind of
It's quite
silly.
simple because it's quite simple, but still you have to have all kinds of resolutions. But in the end, you're looking for inline numbers. They always go with a step, and then it stays the same, and then step stays the same. And crossline numbers is like a sawtooth.
Right.
And that's the kind of thing that you need. And then the coordinates, well, they have to be within a certain system. Then you try to find out, maybe from some headers, whether you can find out what the actual coordinate system is and those kind of things.
Yeah.
Where did they get 1 million SegWi files?
They probably have, but it might also be 100,000. But I always tell this story, so it's impressive. So I say 1 million. But I'm now inviting, if Charles is listening, to come in and tell me what it really is. A lot of files. Yeah.
What do you think about open data? Where can we start to store our open data, and where can we find it?
Well,
reproducibility, man.
From some time ago, and that's basically in our OpenTect format. But if you have it in OpenTect format, then at least you know how to make the SegWi out of it, and you know what you have. And if you get it out of OpenTect, you know where the well is located, you know what the sample rate is, etc. And we may not have the most standard system of the all. So we have a couple of these surveys, we call them, and I think they're heavily used because at least it's test data for all kinds of algorithms, right?
Somebody was joking. I think it was the machine learning and seismic interpretation session at EAGE, and can't remember. Evan told me this story, but somebody joked that it should have been called the F3 session because I think every single data set was the F3 data from CNO and you guys.
Yeah, it's actually, so maybe we should get gravity, but it was actually donated by Wintershall.
Okay, beg your pardon.
Donated in a way, but they said, well, it's okay to publish it, which is quite a bit in many circumstances. But nowadays, I think there's an explosion going on because you can see all data sets have to eventually go to the government, and they are now being made available.
Right.
But we all have seen what happened in the UK, and I think, but they're now, that was, you went to this portal and then you had to choose something, and then the cashier came, right? So it's like, only if you stayed under a certain amount of megabytes, it was to be free. That is not open data. Open data is that you know exactly what you have, and that you can download it as much as you want. And and all the governments want this, so they should sponsor the download costs, and that's it. But the error they made again is to give it to some kind of big company who's supposed to be able to do these things.
Yeah.
And they're able to do it, but they always have their own agenda. So
that's right. I know.
Yeah.
So OpenTect's got the Open Seismic repository, which I've just put a link into the show notes if you're looking for it. What's the future? What's the plan for the Open Seismic repository?
I honestly wouldn't know. I mean, we try to grow, and we are now making like a portal for the Dutch North Sea. But that is, and we want it to be fully free. But the thing is, we cannot pay Amazon ourselves. So we need government subsidization. As soon as we have that, it will be fully free. We'll generate the SegWi files probably on the fly. We have our own internal storage format that's quick and that has all kinds of extra data on it. And that's it. And the Open Seismic repository, we could put anything in it, but these things all depend on whether you can get funding and whether you can get people interested in your stuff.
Are you guys interested in having users put their own data up there?
Absolutely, yeah. If they can give us but we need some structure in it. We need to know
Of
whether
course.
the coordinates are right, and we would want some stuff. But we're open for that, and I think we've always said, if you contribute, it's okay. But up to now, it was that we basically had to go all over the internet and say, oh, I can see they have some stuff there, and then there was this portal, and then you would have to ask for the CD-ROMs, and
Well, one of the
Very,
features of the Open Seismic repository, which I really like, and has actually been one of the great things about OpendTect as well, is that you guys have always been very clear about licensing. When I look at sort of even the open science landscape, but certainly open geoscience stuff, it's very common to find data sets. Well, I mean, just look at half of the SEG, sort of the models and so on. Or cruise, the stuff that comes out of the cruise project, which everyone talks about as open data sets, but there's no license, and you don't know what it is, and you don't know who has the original copy, or whether it's even what you have is like a bootleg or whatever. And you guys have always been very kind of, clear about licensing, and I think that's really important.
I can still remember at a certain point I ordered this cruise data set, and it cost me like 80 euros, and it came. And it turned out to be nothing, complete shit, nothing. It was just some documentation. What the beep?
Okay. Well, I've had that DVD. My DVD does actually have some data on it, but I mean it's pretty raw. Like,
there's some data.
Component field data. I'm like, I don't really know what to do with this.
Who wouldn't want to have 9-component field data for real in actual? Just give it to the community and let them do stuff with it. No, it has to be sponsored this only, and
well, it's copyright, and you can't use it for commercial purposes, whatever that means. And
that is not.
Yeah, so it's basically useless. No, I know.
Yeah,
it's a shame.
I can't even test. I mean, they can tell me that it's like, I mean, it's almost like climate science. Sorry, no.
Don't say that.
Okay. So changing subjects here. Let's talk about the cloud again. So are we going to see OpenTect in the cloud soon?
Yes.
Oh.
But OpenTect already runs. We have running instances in Amazon virtual machines. But what I'm doing right now is making sure that you can, normally if you want to select a SegWi file or something, you have to select on your local disk something.
Right.
And then you say, no, I want to have it from Azure or from Amazon. And it will have this selector, and you pick one and it will take it in.
Yeah,
and it will basically, you can have your entire survey while you're working locally there. But I think the future is, I mean, this is like for a few years, because in a few years you won't even have your local things running anymore.
Right.
You just have a little window there that runs in the cloud, and that's already there.
Yep.
Seeing it working, and you can have arbitrary large machines and everything. It's just that there's quite a bit of money involved. You have to pay these Amazons a lot of money. But that is the future. I can't see anything. Why would an oil company have a large data center with all kinds of people they pay to do stuff? It's completely non-core for them. They should just basically move everything into the cloud. Make sure that all the applications are cloud ready, and be done with it.
How much interest, Bert, have you had from, say, Amazon in sort of, are they interested in what you guys are trying to do there?
Microsoft, I'm now working on Azure first because they were the most helpful ones.
Okay.
And Amazon looks helpful, but they, if you're a program, what you need is some example code that really shows what you're asking.
Yeah.
So I want to know, how do I open a stream, and then, that kind of thing. And Amazon was just like, he was dropping links on me. You could use this and that. And then I still don't have what I need, so I have to figure everything out myself. So I started with Azure, where there was this guy, he went into this, said, okay, this is the code that I made. This does what you just described. And now I'm integrating that. Of course, It's Microsoft, so it doesn't work nicely on Linux. It's a lot of work to get it working. They always say that they're committed to it, but they're not really. So this guy from Microsoft, he also said, I don't really know, because I'm always working on Windows. Yeah, that's fun, but I'm not working on Windows, and it's very essential for us that we keep this platform independent.
So here's a new contest, Matt, for the Software Underground. Let's spin up a cloud-based OpenTect instance and have folks process data or interpret data in some way and come with a winner. I don't know.
Well, but that is not there yet. I mean, you need version 7, and we're now at 6. And in version 7, there will be a full cloud. I can't put that in 6 because it's just break all the interfaces.
Right.
Yeah.
Well, we're waiting with bated breath. When's 7 coming out?
Well, I would. What the least I want. So it's not up to me anymore. I basically stepped out of the line a bit. But what I want is that the SEG conference, I want to have a development release out.
Cool.
So that at least people can start looking at it, or a preview release, whatever you call it. But it's all about resources, and it's just hard because we even had to, it has been a rough time, and we had to let some people go. And it's just very hard to have the resources because we need people to do bug fixing. We need people to do things that actually bring in money, that kind of stuff. Yeah. So I'm constantly fighting to get people on this cloud stuff. And it's very hard to get that. And also I need some people to do that because I also have made all kinds of improvements on color tables, multi-threading behavior, the database. All these things, they need people working on it. I can't do everything myself. Mm-hmm. And that's difficult. It's just difficult. It's just, I can't get everybody. So what I'm trying to do is like what you had. Can you remember the SETI searches? Yeah. That you could basically stuff. So that's what I want to do. So if somebody is not directly on a paying thing, I grab him and say, "Can you do this?"
It's time developer time scavenging.
Yeah, it's
great. You just need an API for it.
Yeah, well,
I have a 9-minute task. Who's got 9 minutes?
Yeah. Well, that would be if you had non-human helpers.
Right.
Probably in 5 years, Matt would probably know more about that, but.
You could probably adapt Uber's software to that problem with like bidding on cost and stuff like that. It's actually an intriguing idea.
Yeah, there's the, what is that called? Amazon?
The Mechanical Turk?
Yes, that's right. Thank you.
Yeah.
Well, no, it's, but that's basically what we're in at the moment. So we have, things are picking up. So I think we've crossed the real danger point. So it's like, but it's going slowly up, and we all now, in the past we all knew that it's going up anyway, but now we don't really know.
No. Feels like it could do anything.
Yeah, it could do anything. So that's let's see what happens. That's the but the problem at the moment is resources for me. So I'm basically trying to get this 7 out in there, and I hope to be able to do it, let's say, at the first of next year. Yeah. But I'm a bit pessimistic on that. But I can at least show you what's going to be there and what we think is the direction of all these things.
Yeah, well, it's great to see it continue to grow as a tool. I mean, like you said, back in 2002, open source software was, almost unheard of. And even today, even if there is quite a bit of open source geophysical software around, there's not a lot of it that's, maintained, well documented, plug-inable, and supported.
Because if you look at, for example, if this document I made for BG, I said, there's like a couple of things you can do. You can do Java size, you can do RSF, you can do, but most of it is, the problem with it is that it's like academic products that basically nobody cares about them.
It's kind of a hack.
There's always somebody caring about it, but you need more than just simple caring. It has to be at least like 5-6 people moving it forward full time. And you can also do that with a large community. You look at Apache and those kind of things, but it's either or. And the whole idea of saying, well, we have had this project within Conoco or something, and we just throw it towards the user community. You have to do work. You have to make sure that people start getting involved, that it's not stopping there, that it keeps growing.
Yeah.
If you have software that works now, well, you have to put maintenance on it because it won't work tomorrow anymore. You know that.
Yeah. Yeah.
And apart from that, it's out of date tomorrow. So, but try to build something from a package of something from 10 years ago. You can't. You can't even build it.
No.
It's impossible.
I feel like I don't know. People have a hard time still in our business, at least, seeing past the immediate revenue problem. Like, well, that's great. That sounds awesome. But how am I going to make my numbers next quarter? Seeing past that to the day when the tool is, widespread and depended upon and becomes a framework or a platform for bigger and sort of better things, which seems like kind of what's happened with, say, I don't know, well, with Linux. I mean, Linux is, the preeminent example, I guess. But I mean, big successful, like QGIS, say, which I think of as sort of a little bit similar to OpenTect in some ways. But I mean, people support that tool because it's now part of the fabric of the sort of GIS community, and enough people depend on it, enough governments and academics and companies depend on it, that it's become a platform, and it's what you develop into if you're not using ArcGIS.
It's always in danger because look at, for example, we had this 3D visualization platform, Coin. It's open and free. It just disappeared. The key people were bought.
What was that? I don't know what that was.
Coin, COIN. So that's why I was. You guys had this Coin riddle before, but Coin was a well. It's still. I'm not really sure whether it's still there, but it's a 3D visualization toolkit in C++. That was good, but we couldn't keep using it because it was dying.
I see.
And that you have constantly have these choices to make. So we've chosen Qt as the user interface, and we've chosen OpenSceneGraph as our 3D visualization. Again, there's one guy, Robert, I can't remember his last name, a Scottish guy, who's basically the center of all the activity in this community. If he goes away, it's gone.
Of OSG.
With OSG, yeah. I'm not really sure, but it loses momentum, and losing momentum is usually a sign of that it's not going on. And then VTK may take over the whole thing.
Right.
Because VTK is still active, and it does Python and everything, and it's so
it's a bit of a beast though.
Exactly, that was what we want is something that's really dedicated. Not too much around it. But
I feel like you could read your email in VTK. It's kind of like Emacs. It's like, you want to play Space Invaders? Great, we have a plugin for that.
Yeah, absolutely. Yeah. So that's really it is actually a problem in grander in bigger design. Is if you have to take in all kinds of dependencies. You can see that with what Microsoft just delivered, the CPP REST stuff. It's dependent on so many libraries that it becomes a problem.
Right.
I can't just deliver my software that works on all Linux platforms. So I have two choices. Yeah. Mm-hmm. Sorry, go on.
Sorry, I was just going to ask when you mentioned Linux there, like, do you know roughly what the install base distribution of operating systems is like for OpenTect? Like, is it kind of mostly Windows and then a bit of Linux and a bit of Mac?
And Windows.
Oh, wow. Okay.
And I would say close to 20% Linux then. And then close to 0 Mac.
Oh, wow. I'm the only Mac guy? That can't be.
There are a few, and they are active. So that's, I mean, we want to keep Mac. I mean, it's not that we're going to drop it. It's just that there's not a lot of active people. There's not a lot of people actually paying. There's none paying. But there's not a lot of people involved. The people who do, they are motivated.
By the way, I guess we should mention on here, how does OpenTect make money?
We make money with, we have like many ways to make money. So, but first we have plugins that are paid. So we have paid plugins. things like access to data stores, like access to Bert Bril. You have to have an OpenTect Plus license. It's still dirt cheap compared to what Bert Bril is doing themselves, but it's still, you have to pay it. So do we make money out of that? We have stuff like Horizon Cube stuff that is paid. So there's a license on it. Second thing is that we of course, we know OpenTect quite well, and you can do quite some specific stuff very well with it, attribute analysis, those kind of things. So we also do studies for oil companies and sometimes non-oil companies, but 98% oil companies to do work for them with OpenTect. So that's the second. Well, the third is basically that you can have us develop plugins.
Mm-hmm.
Hey, somebody said, hey. Okay. So you can have us develop plugins. That's what British Gas did a lot. So they basically wanted to have a lot of functionality. They didn't care whether we put it in the open domain or in our closed domain. We always put it in the open domain, and they just paid for the development. And that was still quite a lot cheaper than to have bespoke, separate software making for them. So that was win-win. We got advancement of OpenTect, and they got what they wanted, basically. So they said, well, we need something there, and they gave us a lot of freedom. So we could really work agile, and that worked very well. Of course, BG is now gone. So and there's not a lot of this work left at this point in time. The oil companies all have more or less shut down this whole branch of work.
Well, I urge our listeners to go over to the OpenTect website, which is linked in the show notes, and go spend some money, baby.
Lots of money.
Hey,
so
Bert.
One thing about this, I just want to say, because Matt was just touching this, it's not just that you can't find the people who have the trust themselves that this will be something. It's also that the outside world should give it the benefit of the doubt in many cases. They should say, okay, it's not that it may not be as good as this professional product, but I should use this because it's the only open thing, and everything I put in here is helping a community rather than only a company. So that's really, I think, if you go to oil companies, they just routinely buy lots and lots of these. Let me not mention the name, but these packages that you can buy for hundreds of thousands Ks.
Yep.
And they just say, well, OpenTect's not good enough. Well, it ain't. Yeah, it's good enough. I think it's good enough, but it's not as good maybe as those ones. But it will not get that way. And also you might be able to do with a little bit less.
Mm-hmm.
But that doesn't come, that's not, they just say, well, these are the requirements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we say, well, we can do 1 to 8, 9 we can do half, and 10 is a bit of a problem. Well, okay.
I've never seen a software tool, though, that, like, I've been involved in lots of those assessments, those software needs assessments and so on. And if they're not basically just reverse engineered right off the bat, so in other words, someone's already made the decision and it's just like, let's choose the parameters that allow us to make that, to justify that decision retroactively. So if they haven't been contaminated like that, you can go and ask, Landmark, well, hey, can we do these things with decision space? Of course they're going to say, yeah, you definitely can. But I mean, every single one of those things, or let's say 50% of them, are going to be a workaround. And they're not going to tell you that. But I mean, fundamentally, that's software, isn't it? If there is something out there that does everything, it'll be a nightmare to use anyway, because it'll have so many buttons on it that you can't actually sort of get your work done. So
have you probably work with the main package in the area? It is like that. It's almost impossible to find anything.
Yes, it is. And consequently, actually, it's ironically, from their point of view, really difficult to do what I think of as really easy things, simple things, I should say, that are actually hidden away, or it's very difficult to understand how to achieve them. And one of the things, I mean, actually would say that OpendTect is quite full-featured. It really does do most of what you want. And the beauty is that if it doesn't do something, you can go and write a plugin to do the bit you want.
Which most people will never consider.
No.
It's something you have to think about. But then,
Sure.
If you really need something, it's on the budgets. What we do nowadays still is to sell stuff like a combination. We do a study for you, and in the process, we make some new stuff.
Yes.
It's all very acceptable. It's really a model that we really like.
Yes.
And but it's as I said. I mean, it's like there is simply no. If we were green and we would be, like circular in economy, etc., we could actually go out and tell these companies, hey, you should use us no matter whether we're the best or not. But we can't do that. But I think it is a similar situation. It's similar situation. I mean, we are trying to make things in such a way that you can see how it's done and what is going on, and other people can actually work with it. And then you go to the Schlumbergers and say, well, you can also work with Bril. Yeah, you can do that, but that means you have to have a 30K just to get one developer's license.
Yeah.
And then you pay like another 30K just to be able to show it to somebody else.
Right.
And then the data you make cannot be used by anybody else, because for that you need at least 100K.
Yeah.
So how open is that?
No, I mean, it's not open at all. And, and I think your argument stands up. Yeah.
I can tell you, we have a connector to Bril. And this connector has a fundamental design that you can simply access it from any operating system with any amount of users. You can basically, because it basically queues everything, and then it.
That's interesting.
We can't deliver it. You cannot use it like that, because they have made a special clause.
Oh, I see.
In their agreement that you can only get a development if you agree that you only work local from the same machine, same user.
Why would you get yourself into that? Why would you sign a contract like that?
Because we can, all the people that
No, not you guys. Like, why do these companies?
Because
that terms like that.
Loads of money. That will cost them loads of money. Yeah. Because we could basically have the whole data loading section. People could do lots of stuff. They could have like 100 people interpreting with just 2 Bril licenses.
Yeah, right.
Because we could basically queue up everything. No, they just sell it in the back of their heads that all these licenses, they're just used for a fraction of what they really are after, and they're just extremely expensive.
Yeah, yeah.
And that is the situation, and that's just because oil industry never cared. They just said, well, it has to be the best, and this is the best. And usually it's also, they have what I would call fake requirements, which is requirements that are, just like you said, reverse engineered to match the product.
Yeah, and there's this sort of
all the time.
There's this like the Microsoft effect where, if you're purchasing business productivity tools, choosing Microsoft for that is a sort of irreproachable decision, right? No one's ever going to come and say that was a crazy decision. What were you thinking? It's like same thing with Bril. It's like, yeah, okay, you chose Bril. That's like the boring choice, and you're not going to get fired for it.
It's risk-free, and it's and same with Microsoft is also in another way. It's very very illustrative. If you go into any Microsoft thing, like you use their cloud thing or whatever, you will find yourself slowly drawn into that you can't go back, because they have all these special things that will only work on Windows, that will only work with this and that. So I'm now trying to use an emulator for Azure that is on Linux, and it's not by Microsoft, because they only have that on Windows,
Right.
So they are not committed to it. They just do it to keep appearances happy.
Yeah.
And that's what's so sad. And I think Microsoft is actually transforming. So Microsoft is going the right way. And so I'm not angry at Microsoft anymore, like I was like 10 years ago.
No,
I'm still angry at those other big ones who are basically just muscling out everybody, not on the grounds of that it's good or anything. They're just using their position.
Yeah. Well, no,
on
I
a
think
level that we can't compete. That you can't compete with.
Yeah, and I think your arguments, like, you could say, well, at the end of the day, Shell can do whatever they like or whatever, which is true. But I think your arguments stand up especially well when you're talking about government, and I think that you can make a really strong case that governments should just, on a matter of principle, use and support open source software in the interest of transparent government.
Make a strong case. And it still doesn't work. I don't know whether you've been in a position, but it still doesn't work because in the government is driven by a little bit. It's driven partly the same as the Shell people, but in a large part, it's driven by this cover your ass.
Right.
So it's the safe choice. They can do the safe choice, or take us. And if they take us, they have just a few people who say, well, that's the right thing to do. You're a good guy. But most of the people don't care less, couldn't care less, and they are ready to hack you. They chop your head off if something goes wrong.
Right.
And that's really what happens. So, but we are I shouldn't say, because we are actually working with governments at the moment, and we hope that it will pan out. But if you look at for TNO, and it's the National Geological Survey, they have loads and loads of licenses of Bril. And I may be corrected, but they may have one or two things from OpendTect, but I think it's zero. Right. So they're simply not. So there's a guy who worked for DGB. He's now at TNO, and he's using OpendTect, and he knows all kinds of stuff that others can't do because they only have Bril.
Yeah, of course.
He likes to do this, and it's good, but it's just not what they do. Yeah. They work with Bril. That's what they do.
Yeah, it's funny how we have created a weird, like, one of the things that really winds me up when I see professors sort of trumpeting, being very proud of getting their students into Bril. Because it's become, or we've made it somehow so important that they have that on their CVs or whatever when they graduate, and that makes me I find that very frustrating. Yeah, that
what happened to science? What happens to science if
and just general skills
start patenting stuff?
Right. Well,
what is going on here?
Yeah,
we have to pay back the society because they've put in money. That is totally against the whole idea of sharing knowledge, and it's mind-boggling, really.
Yeah, no, you're right. They are letting the side down, I think, when they do that, by not promoting openness and a sense of and reproducibility and a sort of sense of community and doing the right thing because it's the right thing to do.
That is really it. But
it's a real missed opportunity.
But this is a sign. I'm just reading a book now I have read the book, but it's like how society. It's basically that managers come in everywhere and take over, as if they know that is the new goal. The goal is to make everything manageable. So if you come into a university and say, well, I can see money coming in, money going out. I can see a way to have less money, so I'm less dependent on the state. I'll do it. Hey, hold on, but that's not what we should be doing, right? We shouldn't be having patents, because patents are the original sin. They're really obstructing all things that we find good. Well, I don't care, because it gives this. So it's happening everywhere. It's why the banks fail. So I just have this little book, and it just explains that this is what's happening. The entire society is being poisoned with it. This kind of thinking.
The embrace of key performance indicators over
key
principles, and you're right. It's the difference between an indicator and actual performance.
Yeah.
Totally.
Well, but if DGB want to pay me on the lines of code that I produce, I can generate a few here and there. No, but you're right. It's
Well, that's that problem solved.
So what are you reading now, Bert?
What am I reading? I'm now reading a book about nudge. It's called Nudge. So it's about that your choices can be engineered without dictating what you choose. You can basically make them steered by somebody. So they give a nice example when they start that if you have a cafeteria where school children eat, by putting the vegetables in front, you could get better choices. You're not coercing anything. You're just saying 20% more fruit is eaten, which is good. Well, that's a good example, but of course there are also examples in which you say this is really very nasty. But
Yes,
well, that's a book I'm reading, and I'm reading a lot every single time.
Yeah.
K.J. Parker. You know K.J. Parker?
No.
I've never read any Parker, no.
No, because it's quite unknown, but it's fantasy without magic.
Okay.
It's
Historical?
well, it's historical, but not real historical. So
Okay.
it is a different country, but it's like in medieval, but a little bit not, and quite funny and really good. So it's what am I reading? No, it's but it's also what I'm also interested in is it's really with my son. My son is at a certain point he became interested in. You could elect him. The young people could elect him as being the representative to the EU for the youth in the Netherlands, but not anything, but only on how do you call it, durability? Just some kind of environmental thing.
Okay,
But
sustainability.
So sustainable, that's the word I can't. So he was beaten.
Okay, that's too bad.
And well, it's too bad, but why was he beaten? Well, the point was that this guy he was up against, I saw a debate. The guy he was up against had no chance at all. He was completely swept away. He didn't know anything. But he did have a community of people on Facebook. So, the elections were on Facebook and he won with a landslide. It's as simple as that.
Huh. That's,
so this is why
eerily sort of reflective of the real world.
It's
Not the real. I mean, it is the real world.
Of real world. But we didn't think of it like that. And now we're thinking about all these things. One of the things is that there is like a technology that can make basically energy dirt cheap, and you don't need oil, you don't need anything, and it's called thorium. It's melting. It's using up metals. It's not. There's no radioactive problem. There is no waste problem. There is there is more than enough for thousands of years. It's just energy. So it's never developed. Why isn't that the case? So if you look at it on the internet, you can find people who are enthusiastic, and I think India is actually starting to go along this path. It's not there because after the Second World War, they chose uranium, which is very, very dangerous stuff, very bad stuff for everybody. And now everybody thinks nuclear energy is a bad thing, but it's not. It's the future. It's the only future we have, and it can make. Because after nuclear splitting, or whatever you call it with thorium, is the fusion.
Right.
So that's the way ahead. It's the only way ahead. But what you see now is that people are going backward. They want to go backward. They want to consume less energy. And they want to make sure that we go back to the state that everybody gets their food from directly the farmer that's across the yard. And I think that is just, I mean, I know this feeling. It feels right. It feels nicer because I can watch it grow and then I can cut it and I can eat it. And my father was a farmer's son and we always had this crop, our own little crop, etc. But it's backward thinking. Similar with renewable fuels. It's super backward thinking. And I would say the worst destruction at this point in time is going on because of renewable fuels. Why is that? You tell me. Renewable fuels are cutting down tropical rainforest at this point in time, and lots of it.
Oh, for pulp, you mean, for sort of biomass?
Pulp and for oil, palm oil, and all these things. That is what happens. And then, of course, if you make these plantations, then the small farmers have no other place to go than yet another piece of true rainforest.
Right.
In the Netherlands, we have the situation that 5% of the electricity generating center, I don't know these, where the electricity comes from, is now from renewable energy. What do? They basically cut woods in Canada to fuel it.
Yeah, that's right.
How bad can you be? The problem is not fossil fuels. The problem is the destruction of the world. That is the problem. And we better stop doing that right now and stop with this ridiculous idea that CO2 is something bad. CO2 is not bad at all. There's nothing wrong with it. It's just that the natural thing that should really make sure that everything is okay. Yeah, if you also destroy that, then what can you do? Then it will never, because desertification is the problem. You could see that in this YouTube video that I basically forced you guys to watch.
We have it linked in the show notes as well. You should check it out. It's a fascinating talk.
It's a fascinating talk, but I mean, can you argue against this before and after? I mean, if you look at this before and after pictures, these photos,
Right.
what on earth are we doing?
It's crazy. And
Everybody has to become a vegetarian. Why?
Yeah.
Everybody has to stop. I mean, no. Don't go backward. Go forward. There's always a solution. We can do. We've always been able to do it. But if you start doing things like that are not really solutions, like trading CO2 rights and those kind of things, then you'll get stuff that is parasiting on that. Similar to well, this is what you see in many situations, that the parasites take over the whole thing. Take stock markets. The parasites take over the whole thing.
Yes,
Stock markets
indeed.
were there for companies to get easier money. And what is happening now is that people are just making money by just doing parasite stuff that's not contributing to our society at all.
Yeah, it's true. I mean, there's all sorts of things mixed up in there too, aren't there? Like subsidies and so on that have these bizarre effects. Like you say, shipping biomass from Nova Scotia to the UK because there are renewable fuel subsidies there for power generation. But clearly, as a system, it makes no sense at all.
It's not just as a system. It's extremely bad. We have a real forest with biodiversity, and we're replacing it with something without biodiversity.
Right.
If
Right.
we replace it in the first place. That is destruction. And you can compare it to what happened in our cities in the 40s, 50s, 60s, 70s of the 20th century. Basically, they destroyed all the nice old buildings to put up all kinds of new stuff. And the destruction is going on. Why? Because there is a group of architects saying that this is what we should be doing.
Mm-hmm. Yeah.
We should make sure that at least the destruction is stopping. The destruction should stop right now. And why isn't that happening? Because everybody has their attention on CO2.
Mm-hmm.
What? CO2? Tell that to somebody 30 years ago. They would say that's impossible. People can't be serious about that. Every single prediction these climatologists have made has not been right on the market. They've always failed. The hockey stick. Can you remember the hockey stick? If that was not, if that wasn't a forgery, if that wasn't on purpose, then at least it was extremely dumb work because it wasn't true. And they admitted it, but that we don't care. We have the new thing, the amount of ice in the Arctic. Well, you may remember that in geological times, most of the times there were no ice caps. Can you remember that? Oh, yeah. So It's
Well, it's change, isn't it? I mean, people are afraid of any kind of change, which is why a lot of why conservation is called conservation. It's all
but
about
conservation should conservate.
maintaining the status quo, because people are terrified of.
Conserve the oceans, for God's sake. Get the big trawlers out of the oceans right now.
Absolutely.
All the money that's now in the CO2 idiocy has to go to real protection of real things that are being destroyed right now as we speak.
Yeah.
You can simply buy all these ships that are fishing and basically kick them on land. And nobody will care because they have their money. Why isn't that done? Because there's so much money in this so-called green economy.
Well, I invite our listeners to continue the debate on the software underground. Unfortunately, we're out of time today, but I want to thank Bert for coming on the show. It's been awesome.
Yeah, thanks, Bert.
I don't know. Did we discuss any geological thing?
I think so. There was a bit in the middle there.
All right, audience. See you next week on Undersampled Radio.